not exist. And so there you go. Okay, so those were the examples where we're taking like a function and then composing it with its function inverse. Now we're going to take a function inverse and compose it with its function. And so it's a little bit of a switch, and you can't assume that they mean the same thing. Okay, because now we're switching from starting with the original function and inserting the inverse function. Now we're starting with the inverse function and then inserting the original function. So let's look at the special cases, and remember these again are shortcuts, but you have to be really careful in order to apply them, because again, they're only true contingent upon the restrictions that are defined. So sine inverse of sine of x equals x for all x in the range of sine inverse. So that would be in the range of negative pi over 2 to pi over 2. And for cosine, cosine inverse of cosine x equals x for all x in the range of cosine, which is from 0 to pi, and then tangent inverse of tangent of x equals x for all of x in the range of tangent inverse, which is from negative pi over 2 open to pi over 2. So just remember, you can only apply these shortcuts if in fact they meet the restrictions and the contingencies there. Okay, so let's take a look at this first one here. It says simplify each of the following. So we're starting with tangent inverse. We're inserting tangent of pi over 6. So we check the range of the tangent inverse, which is from negative pi over 2 to pi over 2. And pi over 6 is in that range. And so we could say that the solution is pi over 6. Let's go ahead and prove it just so that you can verify that it's true. So tangent of pi over 6, that's in quadrant 1. Okay, and pi over 6, we have the values, our x value is the square root of 3 over 2, and our y value is 1/2. And we remember that tangent is sine over cosine, and the y values are sine, the x values are cosine. So let's do a little math here of 1 over 2 divided by the square root of 3 over 2, and that gives us 1 over the square root of 3, which we then change to the square root of 3 over 3. So let's come back up here and go, all right, so the tangent inverse of the tangent of pi over 6 is the square root of 3 over 3. And what I just did there was I worked on my inside value here, and I replaced tangent pi over 6 with its value. And now what I'm going to do is I'm going to solve that. The tangent inverse of the square root of 3 over 3, which we just found right here, is pi over 6. And so you can see that that shortcut holds true, and that is because pi over 6 was in the range of the tangent inverse function. All right, so let's take a look at B. It says, all right, sine inverse of sine of 3 pi over 4. Now, the thing is that 3 pi over 4 is not in the range of the sine inverse, which is between negative pi over 2 and pi over 2. Now, that doesn't mean that this number doesn't exist or this value doesn't exist. It just means that we can't apply the shortcut that says the answer is 3 pi over 4. We are actually going to have to do some work because the special cases rule up here does not apply. So let's go to 3 pi over 4, which is here, and our value for our sine here is the square root of 2 over 2. We don't need the x value for this. We just need the sine value. Okay, so we have that value here. So we are going to go in and replace sine of 3 pi over 4 with its value of the square root of 2 over 2. So I'm just doing a replacement composition here. And then we will evaluate sine inverse of the square root of 2 over 2. Now remember that I have to, this is in my domain. My domain of sine inverse is negative 1 to 1, and the square root of 2 over 2 is equal to about 0.7. So that's definitely in my domain, but we remember that the range is from negative pi over 2 to pi over 2. So since this is a positive value for sine, we're going to be over here where we get positive square root of 2 over 2. It doesn't matter what our x is. And here we are at pi over 4. So the sine inverse of the square root of 2 over 2, which is restricted to this range here, would be pi over 4. So we're going to do a little substitution there, or evaluating that statement. And so the shortcuts are nice, and they're helpful, but of course you have to just remember to stay within the restrictions for the definitions of those shortcuts. Otherwise, you can always just put your pencil to the paper and take a couple extra steps to solve the problems.